Thank you all. Hi, I'm glad to have you at my presentation. Thank you for the support. I'll be speaking throughout this hour about data sources for fuzzing API web apps. A few words about myself. How did I end up here and why am I sharing this? I have solid experience in working with API web apps. I used to do development, application security engineering, pen testing. So I've reviewed this elephant from many sides. I worked at big IT companies where I learned about larger conventional APIs. You cannot always check them manually. That's why I began doing dynamic scanning and automation. I do SAST as well. I develop different scanners for REST API and gRPC. I've even published on this. I prefer to publish the new vulnerabilities in our beloved Russian stack database. API is not just an interface in terms of security. It's an area of risk. If it's broad, it constitutes a large attack surface. To the right, you have some code. It's a basic controller. Just by way of example, hopefully, people do not call SQL through controllers. But at the bottom of the listing, you have a simple SQL vulnerability. It's just an example. We're not going to discuss vulnerabilities. It's just something that everybody knows. So we have an API handle where there is an SQL injectional vulnerability. To detect it, you need to do some testing, do the brackets, quotes, send the quote. But then this handle can have other parameters, not vulnerable to SQL, but still requiring validation. There is a lot of such endpoints in the real world. You have GET, POST, different HTTP methods, and it's continually developing in a large company. You can get 10 new handles, dozens of new handles, hundreds in a big company. It's hard to check, it requires automation. It seems obvious, but manually you will be overwhelmed with a large scope, or you can miss something due to human factor. Here are some examples, not just SQL. In API, you can come across all sorts of vulnerabilities. There are different groupings, injections, comment injection, code injection, depending on the context. There are many misconfigurations where you don't process errors. The API spits out some useful data. You can do debug mode if access control is not properly configured. There are a lot of third-party API frameworks in modern development, a lot of integrations. You often have default settings as well that are not properly reviewed. You're not aware of the keys that have to be sent. And a big group in APIs is access control or broken access control, where the roles are misassigned, the segregations are wrong, and it gives rise to abuses. From function level, where you have privilege escalation, then you have object level, where you get data that are not meant for you, like in IDOR, where you have an ID that's just brute forced in parameters to get other passports. And then you have mass assignments on the property level. You spoof fields in password resets, for example, as if you were an admin. There is a bunch of other vulnerabilities. We'll not be focusing on them today. Just to say that APIs are rich and rife with holes. We'll be discussing fuzzing overall today. We'll compare it to SAST and DAST. To stand up for DAST if you like SAST more. We'll look at key challenges with fuzzing, how to improve it, and we'll source at the data sources that can be helpful. At the end, we'll speak a bit about automation. Knowledge is power, but we want computers to apply them, to crunch the numbers for us to have some more free time. Fuzzing API of web applications. Fuzzing is automated API testing, where you send random or malformed data to APIs, hoping for a response that hints at an error, at a vulnerability, something that you can dig into. The basic idea is simple. Mutation of input data influences the response. That's Postman. You have a form in the request. If the value is as designed, then it's fine. If you pass some SQL syntax there, you have an error. And this means that there is a vulnerability.
Просто берем и масштабируем эту историю, то есть, соответственно, больше поверок, больше уязвимости.
You just scale it with more data and more tests. We test for all endpoints, all methods, all the parameters, which we achieve through automation. We can add various loads. The example is for SQL, but for any type of vulnerability, these parameters would be different. It's also important how you do your analysis of the returns. It's not just that it says an error. You can look at the size of a response, status code, some other parameters as well that can be cross-referenced with unexpected behaviors. Some of such behaviors can be dangerous. A bit of a digression now. Let's see, compare and contrast static and dynamic scanning. Why bother with DAST if you have SAST? So static or dynamic? There are just a few parameters that differ. Static analysis has access to the source code, dynamic doesn't. This makes the target of SAST the code, some patterns calling for unsafe functions like eval, whereas dynamic analysis focuses on the behavior, query response. Now, quotes give you SQL mistakes. There are various tools to do SAST and DAST. SAMGRAB, CodeQL, PT Application Inspector for the former, both enterprise and open source. For DAST, you have Burp, nuclei, PT Blackbox. It would appear that SAST is more effective and should give you full protection because it has access to the source code. You don't have to second guess it, you don't have to generate queries or requests. You scan the code for unsafe patterns and never bother with DAST after that. I fully agree in obvious cases. SAST identifies most egregious errors. Here is a listing from SAMGRAB. To the right, you have vulnerable code, where you have SQL injection in the format code. Again, a very pedestrian example, and most analyzers catch this within their rule set. Here is the next slide, though. To the right, it's not as straightforward, but there is a vulnerability still. Unlike the previous slide, where it's very simple, there is an API controller. This is not my code, it's an actual code from GitHub repository. It has 10,000 stars, it's written in Go, and it's a product that's critical and installed within your perimeter. For some weird reason, maybe it's a backdoor even, the developer transforms SQL queries through a buffer, not a line. They feed it byte by byte, they add some SQL structures, commas, for example, sorting, and then it goes to the database. Well, out of the box, SAST will not detect this. It's pretty weird, nobody's expecting this. It'll be missed. Yes, you can apply a rule for that once you've encountered that. But it can be implemented differently. Coding is creative. And developers have full license to come up with new things. And it's going to be all the same for Dust. It doesn't look at the code. It sends in a quote mark, the character, and the error will be the same, whatever is in the code. It means that the tools are different, that complement each other, not substitute each other. It will be more secure than using just one or the other.
Защитив, точнее, Dust, да, что как бы он нам нужен, и мы не можем от него отказаться.
Yes, we need Dust. I've made my case. Let's now assume that you use it and try to improve the performance of your fuzzing to make it more targeted.
Для того, чтобы проверять API-шку, нам нужно знать по-хорошему endpoints приложения.
To test APIs, you need to know the endpoints, the methods in HTTP that it uses, the parameters that it takes, and the expected value formats. If you are screened out at validation, do not go to business layers. You'll just make the server racks spin, but you will not find any vulnerabilities. It'll be a DDoS attack at best. So where do you get the data? Get the endpoints, know the parameters, and the expected value formats.
И, собственно, что является центральной темой моего доклада.
So this is the main section of my speech. Data sources for fuzzing.
Давайте начнем с самых банальных примеров.
Let's get to it. Here are some basic examples. I think you are all aware of OpenAPI. It's a format for description. It's not as much used in security, but in development. For apps, it's fine to have an API be published for other developers to engage. It's used by pen testers, by internal developers. It can be published on GitLab, GitHub, or available for docs, OpenAPI. It's all over the place. Two formats, YAML and JSON. To the right, it's in YAML. And it has everything that we need. Endpoints, parameters, and values. Values are not always there, but diligent developers have it included. That's something that you can use. There is Swagger as well. It's the same for us, it's just an alter version, so let's skip it. That's Swagger UI, you've seen it across different services. That's for you to look at the API. It's YAML or JSON. This data structure is the same. Once you've seen this, you have OpenAPI. A less evident data source, but also common, is Postman. Basically, it's another standard for web development. Many developers use it. They use it to test API implementations to develop under API-first approach. It's available for free. There is a free version. HTTP client, and documentation is published on GitLab, wikis, or whatnot, because they have the developers, they share it among themselves, and this is where you can get your parameters for testing. It comes as a JSON. The example is right. It has all the same parameters that we've been looking for: endpoints, parameters, and values. It's not one all and be all. There are similar tools. There is Insomnia, Hopscotch, other less frequently used products. If you know that your company or your customer has other similar things, do not overlook them. You can always convert Postman to OpenAPI. Their website has an endpoint. You send the request and it generates a file. You'll see why they need this a bit later. If we haven't found any available descriptions of the API, or OpenAPI or Postman, you can collect some traffic. Here I'm speaking about Burp Suite, a well-known security testing tool. It's become a standard. In our context, it's used as an HTTP proxy. You just run it. You run the app, and you proxy all of its requests through the suite. You engage all the buttons, all the functions, trying to generate all the queries, all the requests, go through all the pages, log in, register, to get a comprehensive picture. It's saved as a history in XML. The example is to the right. It has everything we need: endpoints, parameters, values. There is OWASP, ZAP, and other less common similar products. Do not limit yourself. You can choose. Look at the whole selection. You have the history in Burp. It's easy to export. You select the values or the entire history and just save it. Then we have Proxify, another tool I wanted to highlight. Similar to Burp, but it works as a CLI. It's easier if you want to automate the collection. If you have an intermediate proxy server to look at other requests as well. It's a free project by Project Discovery. This team is well known by its many web security tools. You just run it and proxy the requests from the app, the target app. It can save as JSON, Lime, or YAML. There are similar products as well, Meet Proxy and others. The examples to the right, that's what you get out of it. It has all the parameters that we need, once again. Here is how it looks. You get it from the package manager or directly from GitHub. You run it, it gives you a port, works as a proxy. A more complex yet useful tool is web server journaling or logging. You do logging as a bigger company. For any app, you'd have this. Behaviors, causes of errors, performance under load. It's useful for development, not just security. This is something that you can use. If you know where the logs are, you can get them from the teams, or if you're an attacker, you get access to logs and pull the information that you need from there. For example, this would be Elasticsearch, the go-to solution in logging. It has many free add-ons even, or forks. It stores document in a JSON file. There is no standard for this. This will depend on the infrastructure and the specific company. They can configure the logs. What goes in there, what fields are there. But it will mostly have endpoints, parameters, and values. If you have Elasticsearch present, something similar, you can export it. Export the data. You call an endpoint if you have access or you hacked it. You ask for specific fields and download them for your future use. I think this one is the most interesting out of the cases. You can do commands for load testing, or you can reach out to the load testing teams. You need to load test your APIs as well, on top of security, so that you are sure that all the functionality from the brief works. These teams try to automate tasks. They have infinite time. That's how they test the APIs. And you can take queries from them. Yandex Tank is an open source tool for load testing. It's free and used by testers. It takes in raw HTTP requests as instructions, and it'll contain all the things that we need. And then there are other products like this. You can look for similar solutions again. So you have your data sources. You've come across something. You've received it as a counterparty. You've hacked into somewhere. No matter. You know what the API is, and you can start testing it. To start your test, you need an algorithm first. What you are going to do, and then what steps. You need a stage, bench, or rig. If you do fuzzing on production, nobody will be happy, especially if it crashes. So you have a staging environment. It has to be as similar to production as possible, so that the data and values are as similar as possible to make your finds relevant. The next step is to collect the data, as we've been discussing. Then you have your rig, you have the data, you can come up with checks. They'd be unique to each company. Stats are different, development practices are different, patterns within the companies are different, so it's better customized. If you use this language or the other, your vulnerabilities would be different as well. So you shouldn't test for things that are not there in the first place. Having sorted all of this out, you can start fuzzing. The first two steps are very clear, and I've walked you through them. Then you come to the configuration of checks and launching fuzzing. Are there tools, maybe, that enable you to do this quickly without working on it too much? There are tools, yes. It's called Nuclei, an open source scanner, an app security tool by Project Discovery. It has a number of advantages. The community is big. It has template checks developed by the community. They are engaged with hackers of all sorts, and they are expanding the templates. It used to be a vulnerability scanner, now it does fuzzing as well. Once it has all the data from the sources, it has the map for the app, and by recursion multiplication, it will to, let's say, send a quote to each endpoint in each parameter with each value. So raw vulnerabilities. It's good that it takes different formats of values: OpenAPI, Burp Suite, JSON, Lime, and YAML. It can take those formats. To the right, you see a listing. That's a generic nuclei template. You have a generic header. You set or configure the response analysis. You do the payloads. Again, you see an SQL there. And then you set the fuzzing parameters. You can isolate just the parameters and the query, for example. And then it has a bunch of other finer configurations. It's fun. It's interesting. But it's pretty mature. It has the documentation, so I wouldn't want to read it out instead of my presentation. I have an article on this. It takes you through the steps from just encountering an OpenAPI through to running fuzzing with nuclei. They have their own documentation, and it's been there forever. That's there for your use. So we know that it works with some data formats, but not all. It takes in OpenAPI out of the box, Burp as well, Proxify, obviously, because it's the same team that developed the tool. But not all data sources will be directly usable in nuclei. Assume you have some data from another source that are not taken by nuclei by default. You can normalize them. It's not that difficult. You just need the JSON converter that all developers abhor. You take an example from Proxify and look at the minimal fields that have to be in those JSON lines. You pull the data from your format into JSON line, and it'll be accepted by nuclei to run the fuzzing. That's your basic toolkit for fuzzing. It's all right if you're starting out, but then there are things to learn some more to allow you to find more vulnerabilities and obscure vulnerabilities as well. You can develop your own templates. Nuclei has good templates out of the box, but SQLs are not as tricky. You could develop templates for authorization, for example. Let's say that it gives you 200 at all times, but in JSON, the status code would be 400. That's something that you can account for in your own templates to avoid too many false positives. You can customize it to your own preferences, your infrastructure, or a specific project. You can look at out-of-band interactions as well, where the app makes an external query and you can catch this. Project Discovery has a nice tool, Interact SH, and it's integrated with nuclei natively. It can be deployed within your perimeter as well. Nuclei has nice reports, CRA for Markdown. Command line is nice, but if you have big sets of data, it's better to be exported to store someplace or to convert it into readable reports. This is integrated into CI/CD, as we like. There are example implementations on their repository. So any major list from your app will have a rig, a bench. It'll have a container for nuclei. It'll take the data from where you want, all automated, and will run tests. What's not to like? Just like I said now, automation, getting sources of your data. This can be directly from your storage, or you have a crawler that goes to some neighboring system where you do load testing. And then, if you're still not happy, like I was when nuclei didn't have fuzzing out of the box, you can develop your own shells or packages to run fuzzing, configured to the vulnerabilities that you want to check for, or you can develop your own scanner from scratch. Yes, nuclei is not perfect, and sometimes you have to do this. So we've reviewed API fuzzing in web apps. It's not as difficult. Configuring nuclei using community templates is easy peasy. We've discussed SAST versus DAST. Again, these are two different tools. The overlap is not complete. Some vulnerabilities are better found through dynamic scanning, including fuzzing. Quality fuzzing requires quality data. It shouldn't be random. You need to be targeted per parameter. You'll get fewer false positives and higher quality of alerts. We reviewed the data sources, including OpenAPI, Postman, Burp Suite, Proxify, Yandex Tank, load testing, or logging systems like Elasticsearch. The list is not exhaustive, obviously. Each tool like this has similar products, or you can find the same data in some other way. HTTP is very popular. It's used by many teams in many areas of development. So within the company, you can borrow this from your colleagues or steal it if you're a pen tester. We've looked at all the steps to automate this from scratch. If you've never done this, I suggest nuclei. The barrier to entry is very low. It comes pre-configured. As first step, it's great. You'll see how fuzzing plays out with your infrastructure. You look at the finds, and then you can build this out, do custom checks, catch all the vulnerabilities. It's a rabbit hole. You can really put a lot of effort into this. You can do microservices with nuclei automatically initiated. It takes the data where it needs from, it converts it, it's triggered by events. So the opportunities are endless. You don't have to initiate a scanner in a command line each time. That's it from me. Thank you. I'll be taking your questions gladly. The mics are in the aisles. Thank you for this great presentation. Once again, 2 mics are available in the aisles. Once again, the best question will be rewarded with a book by Peter Publishing House. And to rank the presentation, we value and appreciate your feedback. Okay, questions? Thank you for the interesting presentation. However, you focused a lot on data sources, where different parameters are already structured. So they'll pass through some preliminary filters. Usually, though, for payload to get to the required point, the database has to be in a specific state. It needs to have the values in it, specific values. You have a business flow, and we have requests that come in sequence according to the business logic. It's hard to automate, so you have to do some manual work. You have a sequence of templates to get to the point that's further downstream. Do you have any experience how to improve this? Yes, thank you for this question. It's indeed a challenge. I mentioned this, but in passing. In algorithms, for fuzzing, you have to do staging, and it needs to be as close to the production environment as possible. You have UIDs, will not be validated if it's not in the table, for example, just like you're saying. This is something to aspire towards. That's why you do a staging environment. This can be automated. At bigger companies, there are already production, staging environments, and some more. And this is addressed through the staging environment being as close to production as possible. Hi, thank you for the presentation, very interesting. I have this question. So you collect the endpoints, paths, parameters. Is there a list that you compile? I tried to fuzz APIs. I went around public GitHubs, GitLabs. Is there a list that you have, and does it improve on what's out there in the public? Okay, I get the question. It's been solved many times. You have asset knot, dictionaries, where public documentation is parsed and there are values. If it can be used to enrich your testing, I think it can. OpenAPI doesn't guarantee you access to all the endpoints. Some secret handles can be hidden there, and you can enrich the testing with additional parameters, yes. It's practicable. It's not basic checks from nuclei, where you have a URL. You can have your own templates, like deer busting, or some peculiar parameters. Hello, Всеволод. Over here, very interesting presentation, thank you. At the top of the presentation, you mentioned SAST, and you showed a SEMgraph. Did you consider it as a source for fuzzing, for example? In all languages, APIs are usually defined through templates. If you have a rule in a SEMgraph, with access to the source code, you'll be able to have all the APIs, Boolean, not Boolean, number, not a number, string or not string as well. I think a SEMgraph can find hidden APIs for you if they're not documented or described anywhere. Did you try this? Thank you for this question. A great idea. I'd use CodeQL for this, because it's a declarative language where you can get all the parameters out of there. But I'm not including this in the slides, because I wanted to start with overall available data sources. OpenAPI is out there. If you need a code analyzer for this, it takes some additional effort. Different companies have their own frameworks, patterns. It's something that you can do, but it's a whole job in itself. Okay, out of curiosity, what are the types of vulnerabilities that you can find through fuzzing? Can we identify blind injections that manifest at a later date, or DDoS that cause delays? What are the applications of fuzzing? What types of vulnerabilities? Thank you for the question. You can find most vulnerabilities for fuzzing, if not all. So some things are easier found with SAST. If it's a bad pattern in the code, if you know this, it'll be okay. Dast and fuzzing is better suited for authorization. Multi-user models, it doesn't always come through for the code. Can you use this handle or not? In Dast, you have two tokens. You see user and admin, for example. Simple injections, if errors aren't handled,
в том числе слепые. Про них я упомянул,
including
слайде,
blind
где говорилось,
injections.
как можно улучшить фазинг.
There in the slide
Есть
on improving
инструменты
fuzzing.
для отлова
There are tools
коррекций там и прочих
to catch blind injections and other
SSRF.
SSRFs, like Interact SH.
Интегрируется, и он туда будет отстреливать. И
It's integrated easily. It'll exchange the data. Is it in the slides? The tool that you mentioned?
Да, то есть он просто...
Yeah, it's in the slides. I mentioned it. It's a DNS server HTTP. It logs whatever requests were there, a unique subdomain.
Спасибо за доклад.
Hi,
Подскажи, пожалуйста,
thank you.
можем ли мы настроить наш шаблон для
Is
фазинга
it possible to configure fuzzing
и в том числе
to check for
оценивать слепые зоны,
business check
которые мы на СЗ
and to identify
то есть, поясню,
blind spots that require manual configuration? In WAF, for example, you shouldn't add a check for SQL injections, but there are aspects of business logic that need to be checked. Can we do templates for this? Thank you for the question. Oh, yeah, really, why not? You can check for anything. Nuclei gives you an interface with YAML templates in configs, so you can send raw requests. It can send anything, and then it'll extract values, go to other handles. So it's non-linear. It's supported. It can be any logic. You go one place, you take something from there and the other. Yeah, it's community-driven. People are coming up with all sorts of things. You can execute shell commands from there, and it has entire pipelines. It's not like one query, one response. It asks for a CSRF token, it goes to the other handle, registers, and then it takes a cookie and goes to the third handle, all sorts of arrangements. Okay, thank you. Thank you. I see that we don't have any more questions. What was the best one? Which one did you like?
Мне больше всего понравился вопрос про
I liked the question
то, что нужно разворачивать базу данных.
about the database staging environment. I can see that you've had this issue, so you recognize this. Yeah, we all did. Please come up for your gift. Thanks a lot. Thank you.